You know, we've been here doing this long enough. You know, when you come to class, if you got questions, just come to the board and write them up here, okay? Like, you don't need for me to come in here and tell you to do that. Next thing, let's go ahead right now and let's write the three-step process to solving. I want you to draw your attention over to your left here, this board. I've written a shorthand version of the process. The goal of solving get x alone, so I've solved get x alone. First step is to simplify. We deal with fractions, parentheses, like terms, and getting all our x's to one side. Addition principle, multiplication principle. That's a little shorthand way to do that, so you can trigger, you know, the memorization of that. Go ahead and write that down, okay? Super fast. So the next thing I want to share with you, these look great. That's awesome. Next thing I want to share with you guys is, and this class has been really awesome about this, to be honest with you, but I still want to make sure everybody is on the same page. You should come to class every day prepared, you know, to move on to the next lecture. And, you know, I've said this a million times. Well, okay, I've said this at least, 100 times in my life, but to students, I can't stop the success of the person, okay, that, has initiative, okay? If you take initiative, you'll succeed in anything you do in your life. If you wait for people to, provide you answers, if you wait for people to, be the, source of your success, you're going to be waiting your whole life. You have to grab onto the steering wheel of life and drive yourself to success. Period, in everything you do. And this class, though it's not, entrepreneurial or, business and stuff like that, it still works the same way. And that is, when you get an assignment, you shouldn't just take that assignment and get it done, turn it in, but then you have like 5 or 7 problems on there, you're clueless of what to do, you're just getting the points, okay? You should take those 5 or 7 problems and go to the math lab. You should take those 5 or 7 problems, go to a tutor. You should take those 5 or 7 problems and get on the online chat and have complete closure on that assignment when you come to class. Because some days, when you put these up here, we won't have enough time to go over all your questions, okay? And today's a tight day, and so I think we got time to do all of these, but I'm just saying, I want you to notice, I love answering your questions, and I think it's a really good way to begin each class period, okay? Kind of review what we did, make sure we're solid. But I don't want this to be mistaken as a time for clarification of things you don't understand. It's time to re-emphasize things that maybe you're feeling like you want re-emphasized or foggy on or whatever it may be. But that clarification is something you have to take the initiative to get for yourselves through the resources we provide through tutoring, okay? Okay, so look at this problem right here. Do you have fractions?
Yes.
Well, yes you do. And what's the LCD?
3.
It is 3. Okay, it's the only D. I love tests where there's only one right answer, right? You only got one denominator, so the LCD is 3. And it says in the 3-step process to solving it, and again, we went shorthand on that, but on the big one, it says we have to multiply the things with fractions by the LCD or every term by the LCD? Every term. Okay, and so how many terms are in this expression? 3. 1, 2, 3, right? So we're going to take 3 times x plus 3 times 1/3 x equals 3 times 8. 3x is 3x. These 3's cancel. Agreed?
Mm-hmm.
In essence, isn't this 3 times 1, which is 3, and 3 divided by 3 is 1. 1 times x is x equals 24. Do you have parentheses? No. Like terms? Yes. 3x and x make 4x equals 24. Yeah, are all your x's to one side? Yes, there's no addition principle. We go straight to the multiplication principle, divide each side by 4. And indeed, x equals 6. Okay, it's a good one. Okay, this one right here. Okay. Interesting problem. We'll check it out. Might be one we come back to. Let's do this real quick. Okay, let's do this real quick. Is there anything in the 3-step process to solving that says get rid of decimals? No. We work with decimals. Our calculator is more than happy to do the work for us. Do I have fractions?
No.
No. Parentheses?
Yes.
Yes. What's the distributor of this parentheses?
0.7.
Yeah, 0.7 goes to here and to here. This ends up being 2.1x plus 4.2 equals 1.1. What's the distributor here?
Negative.
It's the negative. Yeah, it goes to here and here, so I have minus x minus 2. Do I have like terms on this side? Here?
No.
Nope. How about here?
Yeah.
Yeah, 1.1, negative 2. So I have 2.1x plus 4.2 equals negative 0.9 minus x. Are all your x's on one side?
No.
So this is the first error that sometimes people make. They'll add x, and they'll add x, get rid of these, and they'll call this 2.2x. Okay, because they add 1 to that 1. This is 3.1x, because that's an entire 1, right? And 1 and 2.1 make 3.1x plus 4.2 equals negative 0.9. You have found simplicity. You can do the addition and multiplication principles. Tell me what to do, quickly.
Subtract 4.2.
Yeah, subtract 4.2, do it to both sides. 3.1x equals negative 5.1. Okay, now what do? Tell me.
Divide.
Yep, we're being multiplied by 3.1, so we're going to do the opposite, divide, do it to both sides. And many of you got to this point here. We have negative 5.1 over 3.1. Now we had a lengthy discussion in the last class period about giving your boss what they want, right? And if you own a business, you have all your customers, they're your bosses, and so it's giving your customers what they want. So we look in the back of the book, and you know, this is one of those moments where I have employees sometimes, and I've told you this, I mentioned it last week, that, you know, they'll be like, oh man, this customer's so dumb, they're so weird, you know, why do they want this? And I'm just like, why do you care? Like, seriously, you're getting paid the same amount. In fact, you might even get paid more. You know, let's just do it the way they want it, right? To me, I'm looking at this, and the whole thing was a decimal problem, right? Decimals to begin with. We end with this fraction and decimal making a baby. We called this a fresimal about a month ago. Remember that? Fraction, decimal, went a little too far, made a baby. Had to see their bishop, gave birth to a fresimal. It's terrible. You know what I'm saying? Maybe they were married. Maybe there's nothing improprietous about this. I don't know. Bottom line is they made a fresimal either way. Okay? We either have to have a fraction or a decimal. Well, it would make sense to divide these two and just have a decimal since it was all decimals, but oh no. They want this answer to be a fraction. Okay? And so, listen, we talked about this. We're going to multiply this by 10 over 10. Okay, what's 10 over 10 equal?
1.
And 1 times anything remains the
Same.
Okay, so we can do this. And where do I come up with 10? Well, that's the 10th place and that's the 10th place. I got to move that. And this ends up being a negative 51 over 31. And you're done. I mean, that fraction cannot be reduced. Okay? And so that gave people some fits. A lot of people, how many of you got to this point right here? Say woo.
Woo.
Okay, and then how many people were kind of having a hard time negotiating that answer? Say See, there you go. Okay? So, that wasn't intended for you. It was intended for the garbage can, and that was a bad throw. Didn't I make one the other day and tell you guys you owe me something for it?
No.
That wasn't your class?
No.
Shut up. You're lying. You know you owe me.
Okay.
Remember that?
No.
That was intended for me.
Oh, really?
Like, after you said it wasn't intended for him, I was like, oh, it was me.
That pen is going WS on me. You know what WS means?
PMS.
PMS? What'd you say? Did you say that? Really? That's funny. No, it's weak sauce. Anyways, what's up?
I was wondering, let's say we're not in this math class and we have to do math like this for, biology or chemistry, like just hypothetically.
Yeah.
When we get that answer, we don't have a textbook to give us the answer. What is the best answer to go with if you don't necessarily have a boss?
Well, I think that you still do have a boss. At that point, it's your teacher. You say, hey, what form do you want this in? That kind of stuff. I think it behooves whoever you're producing for to tell you what they want you to produce, right? But the thing I go back to is, if you're waiting for them to tell you, right? Go back to the beginning of class and I said, take the initiative. Like my customers sometimes, we'll bring something, we'll go through all the trouble, they'll order something, we'll deliver it, and they get it, and it's wrong, okay? Now, here's the deal. They never communicated that they wanted it cut a certain way, or wrapped a certain way, or done a certain way. They just said, I want Levi's, okay? Right? You know what Levi's are, right? Well, do you want a straight cut? Do you want flare? Okay? Do you want,
Boot cut?
What is your boot cut, loose cut, up your butt? Okay. A lot of jeans are up your butt these days, if you haven't noticed. Anyways, kind of weird, So the point is, okay, is that they place an order. I am furious with my employees if they didn't take the initiative to flesh it out. It's not, I get it. They're the order placers, so they should say all the things they want, but sometimes they don't know what they want. Sometimes they haven't thought about it. Sometimes they're too busy, and they need you to do it. So you, as the provider of goods, you always have to go back and say, how would you like this, sir, ma'am? You know what I'm saying? There you go. There's your answer. Okay, ready? Are you guys messing with me? I swore I threw a pen.
No, that wasn't.
It wasn't this class?
I promise it
It was this class?
No.
All right. If I make this pen in the garbage back there, you owe me free beers. Yes?
No.
No.
Root beer.
I don't know. I mean, I'll sell the others on the black market, but either way, I'm making something off this. Yeah, whatever. Okay.
We'll give you.
You're not
Send
agreeing to
no
this?
homework.
No.
If I make this in that back there, in that garbage can, what do you owe me?
We each have to give you a compliment.
A high
A
five.
compliment, a high five. Gosh, this is like marriage. Okay. The gifts are lame.
Hold on.
We'll
Anyways.
give you a feedback on rate my professor.
Can
Give
we,
you a day off, how about that?
can we go to my question as well? Like
We'll take you to
last
Target.
week?
I'll take a day off if I make it. I'll give you a day off if I miss.
Okay.
Alright.
Ready?
What's the difference?
Oh my gosh, you hit the roof. I swear. All right, you get a day off. Wait a minute. Let's go for broke. Did the cap come off? I'm having a hard
Did you
time
take
today.
a chunk off?
I'm usually so. I took a chunk off.
So we don't
Oh,
have
there's the
class
roof.
on Tuesday?
Yeah.
Asbestos right there. Don't breathe that.
Is that where there's something that's in the ceiling?
The ceiling, I mean. Not really.
It's
No,
from
no.
Brother-
All those bits. That's from Brother O'Shaughnessy, man.
Oh, really?
He goes
Throws pens all the
Ape.
time at the wall.
crap crazy in here. Okay, ready?
Oh, that's
Oh.
close.
It's over.
All right, you get a day off. We'll have to figure out which one it is, though. Might be the last day of the semester. Oh my gosh, somebody moved the garbage cans. That's bull crap. I get one more try. Okay.
Oh, jeez.
I gotta give you a pen.
So what's up? There, yeah, never mind.
It's another teacher
This is a
who
busy day.
teaches in this class as well, and every single
Still
time
likes
there's a
that fun.
dead pen, which is like all the time for him,
name?
he throws them.
Caitlin?
And then
Okay.
those are all
My
of
name's
his.
Kaylee.
Nice to
Dang,
meet
that
you.
sucks.
Good to meet you too, Caitlin.
Come down here to this board. You have fractions. Okay. What's the LCD?
12.
It is 12. Okay, but you have denominators of 3, 12, and 4. So 3, what's the prime factorization of 3? Yeah, how about that? Okay, and 4?
2.
Yeah, 2 by 2, so 2 times 2. And 12 is 2 times 6, which is 2 times 3, so this is 2 times 2 times 3. So 3 appeared here once, 0. How many times are you going to count it?
Once.
Once. 2 appears here 0, twice. How many times are you going to count it?
Twice.
Okay, 3 times 2 is 6 times 2 is 12. If you can do it in your head, great. So now you got to multiply 12 times every term. 12 times 5/3. I want everybody to watch this. Plus 12 times 2/3 x equals 12 times 25 over 12. Plus 12 times 5/4 x plus 12 times 3/4. We good? Okay. How many of you are comfortable with cross cancellation? Raise your hands. How many of you are not so comfortable with cross cancellation? Raise your hands. Okay, good. Let's watch this. Do you all agree with me 12 is the same as over 1, over 1, over 1, over 1, over 1? Yes or no? Okay. Let's take this first set of fractions here. Everybody. What is 12 times 5? Well, if you know your times tables, it is 60. And if you don't, you got a calculator. Use it. So and 1 times 3 is 3. So I have 60 over 3, which equals what?
15.
Well, you got a calculator. Use it if you don't know. It's 20. Indeed, it is 20. Okay? Draw your attention up here. Cross cancellation says I multiply those two and then divided by 3. Agreed? I multiply those two and then divided by 3, right? Okay. Cross cancellation says, hey, I don't have to do it in that order. Does 3 go into 12?
Yes.
Yes. How many times does 3 go into 12?
4.
4 times. What's 4 times 5? Oh, fetch me. I don't care which way you do it. You just got to do it. You got me? Okay? See this one right here?
Same thing.
What's 12 times 2?
24.
24 divided by 3? Does 3 go into 12?
Uh-huh.
How many times?
4.
What's 4 times 2x?
8.
You catching what I'm saying here?
Mm.
You can do the long way, you can do the short way. You get me?
Mhm.
So if you're not comfortable with cross cancellation, just multiply them out and then divide it by the denominator. You get me? And you have a calculator and it's your tool and you can use it. You know what I mean? So just do it. Okay? 12 and 12 make what? They make 1. 1 times 25 is 25. Oh, wait a minute. What's 12 times 25? Do that on a calculator, please. Go, right now. 12 times 25.
300.
What?
300.
300. And what's 300 divided by 12? Do it again. Go on. You know? You see what I'm saying? Draw your eyes up here. Please do not look down. Watch this. Please, please, please watch this. Okay? 12 times 25 over 1 times 12. That's this problem right here. Understood? Agreed?
Sweet.
Do you want to know what cross-canceling is? It's using the commutative law to kick A. And I do mean algebra. Look up here. 12 times 25 is the same as 25 times 12. Do you agree?
Mm-hmm.
And if I have that 1 times 12, now the 12 over 12 makes what?
25 over 1.
It makes a 1, and 1 times 25 is 25. But instead of having to rearrange them like that, we just cross-cancel them. Look at this one I just did up here. 12 times 5 over 1 times 3. Do you agree that's 5 times 12 over 1 times 3? Yes or no?
Yes.
What's 5 times 12? 60. What's 1 times 3? 3. But now, if you break that up, you say, hey, that's 5 over 1 times 12 over 3. What's 12 divided by 3?
4.
And 4 times 5 is?
20.
That's cross-canceling. It's just saying, look, because I can move the tops anywhere I want, I can now divide them and simplify it. But instead of having to do all that moving around, I just do it across while they're on top of each other. Understood? That's why it's called cross-canceling. All right. What? You know, sometimes I just want to come up to you guys on the front row and like write on you. It's so fun. You know what I'm saying? It's like, especially when you're wearing masks. You know, you're like, oh, on your hand. Okay? Especially him. I pay him. He should take it. Okay. 12 over 4 makes what?
3.
3. And 3 times 5x is?
15.
15x. 12 over 4 makes?
3.
And 3 times 3 is?
9.
9. Okay. Does this problem look better than that problem?
Yes.
Yeah. You know? Yeah. I mean, that's a makeover right there. You have parentheses?
No.
Like terms?
Yes.
Do you have like terms here?
No.
How about here?
Yes.
Okay, so 25 and 9 make
34.
20 plus 8x equals 34 plus 15x. Are all your x's on one side?
No.
Let's get them there. What do you want to do?
Minus 8.
I like it. Minus 8x. Goodbye. 20 equals 34 plus 7x. Tell me what to do.
Minus 20.
Subtract 34. I got negative 14 equals 7x. What do I do now?
Alright.
Divide by 7, divide by 7. Negative 2 equals x. We're done. Boom. Good?
Good.
Last one. What's the LCD?
15.
What's the LCD?
You.
Me? I'm the LCD? I'm the least common denominator. Girl, I'm the greatest common fetcher. Okay? It is 15. Okay? Now, if you don't know that, you can prime factorize. You need 3, you need 15. Prime factorization of 3 is 3. This is 3 times 5. How many times is 3 appear here? Once it's a tie. 5, 0, once. 3 times 5 is 50. What are you doing in your head? That's cool?
Cool.
Did we smoke oxygen in here?
Yeah.
Did we smoke oxygen in here? Did you get high on oxygen?
I wish.
You wish? Dude, come on, man. How can you not get high on oxygen? It's so good for you. You know?
High on lack of sleep.
It also oxidizes us. That's why we're older.
Mm. Never thought about that. That's deep. Deep. Screw that. I'm gonna hold my breath until I die. Okay. Anyway. All right. So I got to take 15 times 2/3 plus 15 times 3y equals 15 times 5y minus 15 times 2/15. The minus came from there. I don't have the prerogative to only multiply the fractions by 15. I got to multiply every term by 15. We know that from the process. Again, do you want to say 15 times 2 is 30, 30 divided by 3 is 10? Or how about, does 3 go into 15?
Yes.
Yeah.
And it goes in?
5.
And 5 times 2 is? 10. Are you feeling better about cross-canceling?
Uh-huh.
A little bit? Little bit?
Considering I didn't know any of it.
What's that?
Considering I didn't know any of it before, then yes.
Oh, wow. That's rapid learning. 15 times 3 is 45y equals 15 times 5 is 75y. Okay? Is it? Sure.
Yes.
Believe the math teacher. Do these cross cancel?
Yes.
What's 15 times 2?
30.
What's 30 divided by 15?
2.
How about 15 and 15 cancel out and you're left with?
2.
I like cross canceling, you know? First time I saw my wife, I said, "Woman, you are cross canceling in human form. I dig you. Let's go out." You know what I'm saying? You know? My ex-wife saw her, I was like, "Holy crap, you're a motherfracker." You know what I'm saying? Listen, Fetchers, this is all jokes, and you just have to laugh or you fail the class. I had one girl in class, they said, "Rich, your jokes are so bad." I'm like, "My jokes are bad." I'm like, "You guys suck. You don't even tell jokes. You're at 0. At least I'm scoring something here, you know?" She's like, "No, you're in the negative zone." I'm like, "Okay, whatever." All right. What do I do now? What do you guys? I agree. Let's get all our y's to one side. Gone. 10 equals 30y minus 2. You have found simplicity. Let's add 2 to each side. Agreed? We get 12 equals 30y. We divide by 30. We divide by 30. Okay, if you got to this point and you gave up, I'm going to kick your butt. Okay? You know what I'm saying? I mean, we got to simplify that fraction.
2/5.
Okay? What are they both divisible by?
6.
6. I like it. 6 times 2, or 6 times 5. 6's cancel. We're end up with 2/5. Okay? All right, fetchers, that's good. I can erase all this. If you want any pictures or any of that for your knowledge sake, you know, any of those review problems, go for it, do it. So I told you last time you needed to come today prepared to discuss why are some answers no solutions and why are some answers all real numbers. What do you guys think? You got anything for me?
No solutions means there's no solutions. Like there's nothing you can do. It's not just the answer is just 0. It's just nothing.
It's just there's nothing that works, okay?
Isn't it when it's all real numbers? It's because both sides of the equal sign, they equal each other. So no matter what you put in for x, it will always be equal to each other.
You're absolutely right. Both sides of the equal sign equal each other. So you and really, and I don't mean to be, you know, a smart A, and I do mean, yeah, the actual word.
Smart
whatever you think
action?
it is. Something. Is that, you know, both sides of the equal sign should always equal each other, right?
Yeah.
But what you're saying is this. Let's look up here. There was a problem in there that looked like this. X minus 23 equals, you know, we could say negative 23 plus x, or something like that. You know, negative 23 plus x equals whatever, you know, x minus 23. It doesn't matter, okay? We can put it any way we want. Pick a number, any number.
5.
Okay. Let x equal 0. Thank you.
0.
Okay, wait, I
Thank
said
goodness.
5. Okay, well, I'm saying 0. Okay, you guys cool? So where there's an x, I'm going to put in a 0. Agreed? What is 0 minus 23 and negative 23 plus 0? What's 0 minus 23? Negative 23 equals negative 23 plus 0? Negative 23. So what you just said is both sides of the equal sign are the same, okay? All right, so very interesting. When we checked our answers back in 2-1, 2-2, and part of 2-3, when we checked our answers, if we put an answer into the original equation and we came up with a true statement, it meant that answer was what? And it was true. So is this a solution to that equation? Yes or no? Is 0 a solution to this equation? Everybody, yes or no?
Yes.
Well, it has to be because it yielded a true statement. Give me another value. Any value for x.
5.
1.
5, 3. Okay. Let x equal 1. Thank you. Okay. So x minus 23 equals negative 23 plus x. So now we're going to put in 1. 1 minus 23 equals negative 23 plus 1. What's 1 minus 23?
22.
It is negative 22. What's negative 23 plus 1? Negative 22. Okay. Is 1 a solution to this equation?
Yes.
Well, it yielded a true statement, so yes it is. Agreed? But so is 0. And we can play this game all day long. And no matter what you pick, fraction, decimal, integer, it's gonna work. Okay? So let's go back to 5. You're like, well, why didn't you do that in the beginning? Well, 0 and 1 are the easiest numbers to work with. Okay? Watch this. Let x equal 5. All right, we'll do that. Let x equal 5. So we go back to 5 minus 23 equals negative 23 plus 5. What's 5 minus 23? You had to think about that one. So you see why 1 and 0 are sort of friendly? They're user friendly. Get it?
Yep.
Right? The bigger numbers you go, more challenging it becomes. This is negative 18. And you do have a calculator. Negative 23 plus 5, what's that?
Negative 18.
It's negative 18. So is 5 a solution?
Yes.
Everything's a solution. So the answer to this problem is all real numbers, right? Okay.
So what would be a fake number?
A fake number.
Why can't you say all numbers? Numbers are numbers. This is really like some investment.
Do you know, you bring up an awesome concept. God has taught us that there must be an opposition in all things. So if there are real numbers, there are,
Fake numbers.
but we call them
Imaginary.
imaginary numbers.
Imagine that.
Let's not do those.
So, hey, let's not do those. Okay. So if there are real numbers, then there are the opposite of real, which would be fake, which we call imaginary numbers. Imaginary numbers are like imaginary friends. They don't really exist, but they hold value. Okay? And so at a later date, you will learn about those, but not in this class. This is beginning algebra. You learn about that in intermediate algebra and further classes. Okay? So there you go.
Intermediate, meaning what?
Meaning math 101.
Oh, okay.
All right, I was looking for something here. There it is. I spit all over that. Is that bothering you? Doesn't bother me. I don't have to look at it. You do. That thing's dirty though. I mean, I get sick of that. But I guess that's why they have me wear it, because I'd be spitting on you. Front rowers, man. But I'm telling you what, man. You get that on you, you got my DNA. Immediately, you're better at math. You know? Might be a price willing to pay.
Yep.
Plus, I got, COVID antibodies in me now. You know what I'm saying? Drink you some of that. Be better than Moderna vaccine.
Yeah.
Okay?
They only share some spoons when you have the next ice cream.
Sounds good. Would you read this problem to me, young Skywalker, number 76? I'm ready. Do it.
11x
11x.
minus 6
Minus 6.
minus 4x
Minus 4. Let's go fast.
plus 1
Plus 1.
equals 9x minus 8 minus 2x plus 12.
Perfect. Okay. Do you have fractions?
Nope.
Hurry! Do you have fractions?
No.
Parentheses.
No.
Like terms.
Yes.
Yes.
Okay. What are they on this side?
11x and negative 4x.
Okay. What does that make? Hurry!
7x.
7x. Negative 6. Positive 1 make?
Negative
Five.
Come on. Let's go fast. What do we got over here?
9x,
9x. Negative 2x make?
7x.
7x. Negative 8. Positive 12 make?
Positive
Plus 4. Are all your x's on one side?
No.
Subtract 7x. Subtract 7x. What happened to the x's?
Cancel.
Go away.
Saya Fechinara. Negative 5 equals 4. Right? Okay?
No solution.
I want to show you something interesting here. Okay? When we solved this problem, okay, which we didn't solve this problem, okay, look up here. At x minus 23 equals negative 23 plus x. Fractions.
No.
Parentheses.
No.
Like terms.
Yes.
No. You don't have like terms here, and you don't have them here. Are all your x's to one side?
No.
Get them to one side. What do?
Minus X.
Subtract x. Subtract x. X is canceled out. You got negative 23 equals negative 23. False or true statement?
True.
True. What was the answer to this problem right here? All real numbers. Okay? Because everything's working, right? You solve this one, sorry. You solve this one. Okay? Variables canceled out. Is that a true statement? No. The answer to this is no solutions. Give me a number, any number.
2. 0.
1.
0. Gotta learn from your mistakes, people. Okay, let x equal 0. All eyes up here, okay? What's 11 times 0? Help me.
0.
0 minus 6 minus
0.
0 plus 1 equals 0 minus 8 minus 0 plus 12. Agreed?
Yeah.
Right? If I let x equal 0, because all those things times 0 will be 0. 0 minus 6 minus 0 plus 1, negative 5. Equals 0 minus 8 plus 12, positive 4. Okay? Same thing that we got right here. Okay? Does 0 work?
No.
Pick a number, any number. Give me another one.
1.
You're starting to learn. 1. Okay, good. All right. 1 times 11.
11.
11 minus 6 minus.
Negative 4.
Okay, so negative 4 plus 1 equals
9.
9 minus 8
Minus 2.
Minus 2.
minus 2
Plus 12.
plus 12. Okay, so when you put a 1 in for all those, just multiply them. It's easy, okay? 11 minus 6 is 5 minus 4 is 1 plus 1 is 2. 9 minus 8 is 1 minus 2 is negative 1 plus 12 is 11. Does 2 equal 11?
No.
And we can play this game all day long. And nothing's ever going to work. There are no solutions. So, I want you to write something down right now. I'm going to erase this board on the left, and I want you to write while I'm writing, okay? It is the summation of all the knowledge about all real numbers and no solutions, okay? Now, I went to great lengths and depths to show you, literally, how every answer works and no answer works and all that kind of stuff. But I want you to write this down right now, okay? When I'm solving and my variables cancel out, I'm left with either 1, a true statement, i.e. negative 23 equals negative 23, or 2, a false statement, i.e. what? Negative 5 equals 4. Okay. In which case my answer is all real numbers, or in this instance, no solutions. Does that make sense? Does that make sense? Or no? Look up here. I solved this, and look at my variables canceled out, and I was left with a true statement. And my answer was all real numbers. I solved this, my variables canceled out, and I was left with a false statement. There are no solutions. Okay? And your variables don't cancel out very often, but when they do, you either have all real numbers or you have no solutions. Now let me show you something that happens sometimes though. Can I just show you? Because I did this with you guys last time in class. Okay? See this right here, this x minus 23 equals negative 23 plus x. See that? I do get the occasional student that instead of following that religiously, they skip getting all their variables to one side and go right to the addition principle, and they say, oh, I'm going to add 23 and add 23. Then these cancel out, and they're left with x equals x. Say woo if that happened to you.
Woo.
Okay? Your variables didn't cancel out. Pick a number, any number.
1.
0.
If x equals 0, so does the other x. 0 equals 0. If x equals 1, 1 equals 1. 7, 7 and 7. 5, 5 and 5. You get me? All real numbers. You catch me? Now in the no solutions, you'll have to cancel them out to solve the equation. It's the only way it works. So they will cancel each other out. And you'll get a false statement. Yes?
Okay, sorry if this is stupid, but if, so for like negative 5 equals 4, what stops you from like saying like, oh, +5 to the other side?
Hmm?
Like, what
Can I
stops
add 5
the
to this side?
equation?
Can I add 5 to this side?
Yeah, like what stops the equation from going like +5 on
Okay.
both sides?
Okay, so if I say -5 plus 5, but I have to do this to this side too. 5 minus 5 is 0, 4 plus 5 equals 9. I still have a dumb statement that's
Okay.
false, right?
Okay.
This is like when your child gets in an argument with you when they're a teenager, you know? And they just dig a deeper hole for themselves.
Okay.
Like, okay, you just made a stupid statement. Well, I'm gonna add 5 to both sides. Well, that's even dumber, okay? You know what I'm saying?
So you never take
So
away
it wasn't
the
a dumb
equal sign
question.
either.
It was a great question that led to a dumb answer.
Yeah. So you just never take away the equal sign. Like
No.
the equal sign always stays there on
Yeah.
solved problems.
Yeah. Yep. Cool? Guys good? Okay. The main thing is that when you are solving an equation, you have to understand, you know, when you end up, the variables cancel out, you have an all real number and no solution situation. Okay? Okay. Good enough. I have to erase everything up here, take pictures, write notes, do what you need to do, but I'm going to erase the middle board here in about 5 seconds.
Do we still have time for my question? I said Friday
What'd you ask, Friday?
about why we use numbers and letters kind of thing.
I gave you a good answer after class, remember that?
Yeah.
Yeah,
I forgot it.
me too. That's how good it was. We both forgot.
I think I remember it.
Give me a hint.
I think you use money in like tithing and something.
Okay. You guys know what scalability is in business?
No.
Scalability. Anybody say yes if you do?
No.
Does anybody want to give a crack at what is scalability? Okay. If I make really good desserts, you ever gonna get unplugged, girl? Am I gonna have to mess with you? Come on. You're plugged in. Come on, man. I can break my phone and do the same thing. You gotta stop. You gotta do this. You gotta check in with me here. I love you enough to chastise you. God tells us the same thing. Not that I'm godlike, but yeah. Anyways. Scalability. If I make really good desserts, and people like them, okay, people will buy these. So I make some really good desserts. But I can only make, you know, like so many desserts a day, and I've run out of time. You get what I'm saying? And so I'm making, like, I've got to the point where I can make 100 desserts a day. That's a lot, but I'm working around the clock. And I'm making a few bucks off of each one. I'm only making a few $100s a day. So I got to scale my business. Scalability is, can I take this to another level where I can actually make money and sell thousands of these? What do I got to do? Invest in what?
Hire people.
People, right. I got to have more cooks, or maybe we got to have bigger ovens, or, you know what I'm saying? We got to have
Increase
something
the
that allows it to be scalable. All eyes up here. If I find a random Muslim today, and I say, I'm going to teach you the concept of tithing, and all I tell them is, how much money did you make? And they say, I made $500. Okay, your tithing is
50 bucks.
50 bucks. Okay, so your tithing equals $50. Okay? And then I say, do you understand the principle of tithing? And they're like, yeah. I'm like, okay, how much do you pay on $300? And they say, 50 bucks. Why wouldn't they say 50 bucks?
It's not 100%.
Because you haven't given them a second example.
I haven't
So they
given them a
can't see a
second
pattern.
example. Okay, ready for this? Algebra mixes numbers with letters so we can scale math. That right there limits our knowledge. If it's only numbers we're dealing with in math, then we can only deal with one instance at a time. I can only know from this that when I make $500, I pay tithing of 50 bucks. But if I say T equals 0.10I, and T stands for tithing and I stands for income, I now have an equation and I can find tithing for an infinite amount. I have now scaled math. I can find tithing for not just 100 different incomes, 1,000 different incomes, infinite incomes. That's the power of algebra. That's the why of letters mixed with numbers. We clear? So the day you got pissed off when the teacher said, y equals mx plus b, and you're like, kiss my butt. Because you're like, why can't we just work with numbers? I don't blame you. We all went through that. We're like, what happened to 1 plus 1 equals 2? 5 plus 5 equals 10. Why do we have to deal with this? Because we got to go beyond just making cookies for the local people in your ward. We want to sell cookies all over the nation, right? And we got to scale this. Make not hundreds of dollars, but hundreds of thousands of dollars. Understood? Okay. It's a great question. There's a better answer.
Cool.
And humility, it's for the weak. But they will inherit the earth. That's cool. Okay, we're up here. I'm not saying you're weak, I'm saying. Bad moment to slap your shoulder. Okay. Okay, everybody, on the count of 3, listen to me. Okay? Who has COVID in here? Raise your hand. Anybody feeling a little sick? Liars. Okay. Are you feeling a little sick?
Just tired.
Okay. Everybody on the count of 3, I want you to go, ah! 1, 2, 3.
Ah.
You sounded better than my church choir. and it's supposed to be a guttural, ah! Like it should bring pain and resonance of, you know. Okay, 1, 2, 3.
Ah.
You sound like you just burped up your lunch.
Peanut butter baby.
All right, sure.
Oh, so like we're trying to get our war face on, right?
That's what I was hoping for. But we're too late now. We're on to solving formulas. Okay. What's a formula?
You just gave an example of
A form and a ULA.
I just give you an example of
it.
one.
D I equals.
The tithing formula. Good job. Good job. Okay. A equals 1/2 BH. That's the formula for what?
The perimeter of a
rectangle.
square.
The area of a.
Rectangle.
Okay. A stands for. B stands for. H stands for. I love you. Okay. Thank you. That's good.
Perimeter.
In your book today, it's going to say solve for B. Okay? Solve for B. That means, look up here, 3-step process of solving. Instead of getting X alone, we're going to get what alone? B. Get B alone. Who's sharing sides with B right now? H and? Okay, let's go through the 3-step process of solving. Do you have fractions?
Yes.
What's the LCD?
2.
It's the only D, it's 2. So I'm going to multiply 2 times A. Now I got a question for you, and I would not be putting your head down, I would not be writing right now. I'd watch this, because I can make homework easy tonight, but if you don't look at this, homework's going to be a challenge tonight. How many terms are on this side of the equal sign? Right here.
1.
1. How many on this side?
There's
3.
3.
1.
BH is 1. Wait, 1/2 BH?
1.
1!
1.
About ready to give you another finger, okay? 1! I defined term with you a while back ago. Terms are separated by what?
Addition, subtraction, and times.
Plus and minus signs only, not multiplication or division. Addition and subtraction. Plus or minus signs. How many plus or minus signs do you see there?
0.
Okay? How many terms are there?
1.
That's really important because see, now you multiply 2 times 1/2 BH. If you did it your way, we multiplied 2 times 1/2, 2 times B, 2 times H, and we would end up with 4BH, which is not true because these cancel out, and what are we left with? Just BH. 2A equals BH. We clear? Don't forget this. Powerful. Okay? Who's sharing sides with B?
H.
Well, before we go there, do we have any parentheses?
No.
Like terms, meaning other little bees running around. No? All your bees on one side?
Yes.
Yes. Some of you are giggling.
It's like
You know,
we're
Mormons are
getting
funny
ITC.
because they can't swear, right? And so they make up little letters of the alphabet to represent their little swear pseudonyms. You know? Oh, you little B. What the H? I'm going to kick your A. I'm dropping the F-bomb. Okay? All of these little alphabet letters. So whenever I teach formulas, I always have students like, hee hee, ooh, you know? And I start saying, hey, little B, I'm going to kick you. Anyways. It's just fun.
BH.
Okay? who, I know, all of those, big A, little b, H, they all have meaning for Mormons. Everybody else, no, it's alphabetical. For you guys, it's squarical. Okay, listen.
Squircle.
Yeah, that's a word. Just ask your English teacher. Okay, what do we do now? Help me.
Divide by H.
Divide by H, divide by H. What the H? Exactly. And so I end up with 2A over H equals little b. And we're done. Because B is alone. Now you have the formula for the base of a triangle. Okay? Gonna have you do one right now. No, I'm not. Do you want to do this one on your own? Or do you want to do it with me? With me? Or on your own?
With you.
Do on around and then with you.
I like it. Okay, I want you to solve for W. Okay, go. Can I just tell you that in your homework tonight, I think you'll find the majority of the problems to be relatively easy. But these three, each one of them has a little nuance, a little hiccup that, can cause you a brain fart. And I want to help you through these, okay? So the brain fart on this one, look up here, was that you thought that was 3 terms. And it's just 1 term because everything's being multiplied. You got to remember that for the rest of your lives in algebra. That's 1 term. Okay? I want you guys to help me out right here. What's the first thing I should do?
Subtract.
I agree. Subtract 2L. There were no fractions. There were no parentheses. There were no like terms, meaning other W's. Okay? All your W's are on one side. We go to the addition principle. We got P minus 2L equals, these cancel, 2W. Say woo if you got to that point.
Woo.
Okay, that's great. Who's sharing sides with W?
2.
What's it doing?
Multiply.
What are you going to do?
Divide.
Now, I'm curious. Did you divide this by 2 and all of this by 2, or did you break it up 2 and 2?
Break it up.
Okay? And that would make sense that you broke it up. But this is the answer right here. P minus 2L over 2 equals W. And that is it. And you could rewrite it as W equals P minus 2L over 2. Put the W over to the left. That's no big deal. But that is the preferred answer for that problem. All eyes up here. Drop your pens and pencils. Don't work on that other problem. Look up here. Come on. I am teaching these little things. When you get to this point, P minus 2L over 2, I want you to understand this. It also equals P over 2 minus 2L over 2. Okay? You have to understand when you put everything over a single denominator, you can put each term over that denominator. Each term in the numerator over that single denominator. I'm going to teach you something powerful right now. This right here, how many terms is this?
1.
It is 1. Brother Rich, you said terms are separated by plus or minus sign. It's true, but they're all over one denominator right now, which unites it as 1 term. How many terms are right here?
2.
That's 2 terms. And these 2 things are the same. They are the same. Because P over 2 minus 2L over 2, we can put it all over 2 because they have the same denominator. Okay? Look at this. This also equals P over 2 minus L. Why? Because those 2's can cancel out. Okay? It's not acceptable. I'm saying it's not acceptable. I'm saying we don't write this as the answer. We don't write this as the answer. We stick with this. Now, one thing you can't do, look up here, and if any of you did it, you can't go like that. Why can't you do it? Because that 2 is underneath that P as well. You have to separate them to simplify them if you're going to do that. And that's where that other one came in, okay? You guys cool with that? Mm-hmm. Okay, last one of this section. We still have some more stuff to teach you, so we got to keep moving. Okay, told you today we had to move along. Okay, do you have fractions?
Yes.
What is the LCD?
3.
So we got to multiply everything by 3. How many terms over here?
1.
How many terms over here?
1.
You learned something. Good job, you learned it over here. So we're going to multiply 3 here and 3 here. So we're going to have 3 times A equals 3 times A plus B plus C all over 3. And those 3's are going to cancel each other out. And we're going to get rid of fractions. So now we have 3A equals A plus B plus C. Understood? And why is this one term? Because it's all over one denominator. Cool? Do you understand? A plus B plus C all over 3 equals A over 3 plus B over 3 plus C over 3. Yes or no? They are the same thing. Okay? To get rid of that fraction, I would multiply this by 3. To get rid of these fractions, I would have to multiply each one by 3, which makes sense because 3 goes to this and this and that. You get what I'm saying? This would create A plus B plus C. Cancel, cancel, cancel. This creates A plus B plus C. Okay? Coming back to this. You want B to be alone? What do you do next? Tell me. Minus A. Minus A. Big A's and little A's. That's worth laughing about. Are they the same? Are they like terms? No. Lowercase and uppercase different. Okay? So those are not like terms. So you have 3A minus little a equals B plus C. Now what did you do? Minus C. Exactly. So you got 3A minus little a minus C equals B, and you're done. Take pictures of that. That'll help you through your homework. Okay? Open up your books to page 166. If you don't have your textbook, get your Canvas open and look at the printed assignment. You gotta hurry. We got some more stuff to do. I'm gonna get out of your way. I'm gonna erase this board over here. It is done. Got all that. Okay. Problems 1, 3, 5, 7, and 9 in your homework look like word problems. They are not word problems. They are, I want everybody to go, "Bleh," right now. 1, 2, 3. They are sheep in wolves' clothing.
Oh.
Usually it's a wolf in sheep's clothing, right? These are sheep in wolves' clothing. They look bad, mean, and word problem-y, but they're really little baby sheep. Read the first problem. Look up here. It says that in New England, that the furnace output for I think is it big B and little a? What is it?
Big B and little a.
Big B and little a? That's some funny stuff too. Okay? All right. This is the formula for the furnace output of where B equals BTUs and A equals square foot of a home. Part A of the assignment says, what is the BTUs or the furnace output for a 1900 square foot home? Help me. Where does 1900 go? For A or for B?
A.
Yeah, so look up here. We say B equals 30 times 1900. Therefore, B equals 57,000 BTUs. Done. Hard or easy?
Easy.
Pretty easy. Look at part B says, it says take the equation B equals 30A and solve for A. That means to get little a alone. What do? Divide by 30, divide by 30, and you get B over 30 equals A. And you're done. Pretty easy stuff. Okay? Just wanted you to see that real quick. Take a picture of that. Can I erase the middle board? Middle board.
Yes.
Okay. You have 2 assignments tonight. And the second one is in 2.5. And I'm going to show you in just a few minutes how to do it. I think you're going to be pleased. It's very easy stuff. Okay? But I'm going to write this down real quick. We are not doing all of section 2.5 tonight. Don't go past whatever numbers, 27 or 29. And these are what we call the is of what percent problems. And in these problems, we do something that we call our tool that we use is called drop down translation. Okay? And we have to understand that is means equals, of always means multiply, what or some number, what number or some number, they both mean the variable. Okay? And you can pick any letter you want for it, but often we just say it's X. And then the other thing you have to know is that we always convert percent to a decimal, okay, in order to work with it. If I have 50 is percent of what number? Okay, 50 is 12% of what number? All eyes up here, watch this, I'm gonna help this go faster you. Look up here. 50, that translates to 50 in math. Is, what's that? Equals. 12%, we always convert it to a decimal, so what does that become? 0.12. Of means what? Multiply. What number means what? X. Who's sharing sides with X? 0.12.
0.12.
What's it doing?
Multiplying by
What's the opposite of multiplication?
division.
Do it to this side. Get your calculators out. Do 50 divided by 0.12. Go. Hurry.
416. Sorry, never mind.
416.6 with like a dash over it.
Yeah, there we go.
Y'all agree?
Mm-hmm.
You did 50 divided by 12. I agree. Okay. Hard or easy? Okay, let's do another one. What if I have 18, or no, yeah, 18 is what percent of, that's a C there, of 60, okay? 18 is what percent of 60? Okay, drop down, translate, right? 18 is equals what percent? X of times 60. Who's sharing sides with 60? Or X, sorry? 60. We're gonna divide. Get your calculators out to 18 divided by 60. Go. Hurry.
0.3.
0.3.
3.
0.3 equals X.
0.3.
Yeah.
That's it.
Yep.
Okay. 0.3 equals X. Are we done?
Percent.
They asked for what?
Percent.
Wait a minute. I told you to always convert percent to a decimal. Unless they ask for a percent, then you must convert back. Okay? And so this becomes 30% equals X. You guys good? That's it. You can handle everything you got to do tonight based on this knowledge, okay? Can I get an amen?
Amen.
Amen.
How many of you ever took, you guys, it's time to go, you're sitting here. How many of you ever took one of those tests that tells you what you should do for a profession? You know what I'm talking about? It analyzes everything. What did it say for you?
Teacher.
Teacher? Okay.
Yeah.
Mine said I should have been a preacher. I'll tell you what, when I went in to take that test, it took me hours. There was like hundreds of questions on it. And I literally thought this was going to be like my patriarchal blessing. It was going to reveal my destination and my destiny. And it told me I was going to be a preacher, and I was so ticked off because I was a Mormon, right? I'm like, there's no paid clergy. You know?